Alright guys, we're here to talk about the 2.3 notes today. In 2.3 it's going to be using mostly two-step equations, but every once in a while there's a one-step equation. And we're going to be taking some words and word problems and turning them into our two-step equations. Alright, so the first thing we want to think about here are some words that you would typically think of that stand for addition, subtraction, multiplication, or division. All right, so that's what we're going to start out with here at the top of the paper. All right, so some words that we need to know for addition would be add, altogether, both, combined, how many, increase, join, plus, sum, together, and total. And these are just some of them. There are more, and they're used in many ways. A lot of times we need to know sum is used a lot. Total is used a lot for us. Okay. There's others that are used, like I said, but those two are really used a lot. And then most of these other ones are used throughout the lesson as well. Okay. Moving over to subtraction. Obviously we have subtract, deduct, decrease by, difference, sometimes it's just a question of how many more, or how many are left. Sometimes it asks about leftover. What's left over? Less than. That's one that we use a lot, and there's something special that happens with that word that we'll talk about quite a bit. Sometimes people use minus, remains, remove, and take away. Again, there are others, but these are the ones that we need to know a lot. Less than is used all the time in this lesson, and difference, again, is another one that's used a lot. Okay? All right, so moving down, we're now going to talk about multiplication and division. So over here on the left side, we have multiply. As much, by, equal groups, groups of, per, P-E-R, it's used fairly frequently, product, that's used a lot, times, and the word of. Again, of is used a lot for multiplication. Okay, and then the last type of situation we're going to use here is division. Okay, and we have divide, average, each, equal parts, evenly, every, out of, quotient, which is used a lot, ratio is used a good amount, shared equally, split, okay? But definitely by far, quotient and ratio are talked about probably more than any of the other ones, okay? So again, those are all some of the many words that could be used for addition, subtraction, multiplication, and division. And I tried to focus in on basically 2 words for each one of those that we use a lot in 2.3 and in our life, all right? So here we go. Now that we've kind of talked about some of those words, we're going to figure out how to use those words to help us write some 2-step equations. So it says some verbal sentences translate into 2-step equations. All right? And here in example 1, it says translate each sentence into an equation. Okay? So if we read these, we're going to kind of point out some of those important words. More than, okay, so more than means addition. 3 times a number means multiply. Anytime we see a number, this is going to be our variable, okay? And we can pick any variable that we want to use most of the time. Sometimes it says to use a specific number like a number X. Or maybe the problem is a real-world problem, and we're talking about the number of pounds. So we wanted to use P for pounds because that makes sense with the problem, okay? But technically, you could use pretty much any variable that you wanted to use, okay? The other thing that's important is the word is. Is means equal, and we see that in almost every one of those, okay? So if we look over here to the side, we have 3n, okay, that's 3 times a number, plus 4 equals 19. It's also worth noting that when we have addition, this really could be written as 4 plus 3n equals 19, and it's the same thing, all right? The next one, 5 is 7 less than, okay? So I meant to circle is, not underline 7, and then twice a number. When we see the word less than, this is the one where our order flips around, okay? So if we look over here, it says 5 is, we know equals, so 5 equals, and then the word less than says subtraction, but what it does is it flips our number around, okay? So instead of being 7 subtract 2n, because it's less than, the order of those 2 things flips. So as you look over here, the 2n comes first, and then we subtract 7 from that, okay? That's the one that trips up a lot of students, okay? The next one, we have 7 more than, so we know more than means addition. We have the word quotient, which means division, or a lot of times people write this as a fraction, okay? So 7 more than the quotient of a number and 3 is 10. So we slide it over here. So we have 7 plus n divided by 3 equals 10. And again, it is worth noting that because we have that addition, we could put the fraction first of n divided by 3 plus 7 equals 10, and it gives us the same answer. Okay? So anytime we're using that addition, the order of the 2 numbers doesn't matter. But if we have a subtraction problem, the order of the 2 numbers matter, and that's something that, like I said earlier, trips up a lot of students. Okay? All right. The next part of this is, for example 2, it's basically saying that after a sentence has been translated into a 2-step equation, then we can go ahead and we can solve the equation of it. So just like what we were doing in 2.2 with our 2-step equations, okay? So we had some word problems on our 2.2 quiz, but the equations were already set up for us. So now what we're going to have is we're going to have some of those real-world type problems, and we need to create the equation and then also solve them on top of it, okay? All right, so example 2 says translate the sentence into an equation and then find the number. Says 13 more than 5 times a number is 28. So again, keyword more than means addition, times means multiply. A number, again, is whatever variable we choose, and is means equal. Okay? So they rewrote it over here, which is 5n plus 13 equals 28. We go ahead and draw on that line to help us out and keep the left side and the right side separate. We pay attention to the left side because that's where our variable's at, and so we either have an option of getting rid of the 5 or getting rid of the 13. We know, because of what we've talked about in 2.2, that we want to get rid of the 13. So we pay attention to the sign in front of it, which is a plus sign. So we want to do the opposite of that, which is subtract 13. And because I do that on the left side, I need to do the same thing on the right side. We subtract, which gives us 5n equals 15. And then we know anytime we have a number in front of our variable, we want to divide, because technically there's multiplication between the 5 and the n. So we're dividing each side by 5. On the left, that cancels out to give us 1n, or just n by itself. And then on the right side, 15 divided by 5 is 3. It is also, just like what we were doing in 2.2 and 2.1, you could take that number and plug it back in and make sure that it works before you move on, which is always what you should do. I know some of you are better at that than others, okay? But it is another option that you can plug it back in and see if you are correct before you move on, okay? So here we go. We're going to do some exercises that are similar to example 1, where we are writing it out into an equation, all right? So it says define a variable. Again, when it says define a variable, that's basically your choice. But sometimes it is better to use a variable that stands for something in the problem. So sometimes it's easy, like I said, if it was talking about miles, okay, that's what we were trying to find. Using the letter M would make more sense to use. So that's what it means by defining a variable, okay? So after you define the variable, then you translate each sentence into an equation, and then it says we're going to find each number, okay? So we are going to go ahead and solve these out as well. All right, so here we go. Number 1 says 5 more than, so more than means addition, twice a number, okay? The word twice means 2 times a number, and then the word is equals, okay? So here we go, 5 plus 2. Again, we don't have a specific thing that our number is, so we get to pick any variable. Most people use x because it's common. All right, and then we go ahead and we start to solve our equation. So we subtract 5, we drop the 2x, 7 minus 5 is 2, and then we divide each side by 2 to get x equals 1. And that's it. Okay, so after we have the equation written out, it's exactly what we were doing in 2.2 with solving the equations. All right, number 2, we have 14 more than 3 times, so again, times means multiply, a number is 2. So we've got 14 plus 3 times n for a number equals 2. Again, that variable is your choice. You could use any letter you want. We're ready to go ahead and subtract 14 on each side. The 3n drops down, and 2 minus 14 is negative 12. We divide each side by 3, and our number is negative 4. All right, number 3, we have 7 less than. Okay, and we talked about this earlier. So less than is subtraction, and anytime we're dealing with subtraction, we need to be careful. Specifically, the words less than, because with those words, the order of our numbers flip around. So 7 minus twice a number is what a lot of people would like to do, but because we have the words less than, we're going to switch that order. So it should be 2n minus 7 equals 5, okay? So do not keep that order the same, right? And then because I wrote it down there a little bit further than normal, I'm going to just rewrite it over here to the side so that we have more room to solve it. So we want to get rid of the 7. We notice there's a subtraction sign in front of it, so we're going to add 7 to make that become 0. The 2n drops down. 5 plus 7 is 12. We know that it's multiplication between the 2 and the n, so we're dividing by 2 to get rid of that. The 1n drops down, and 12 divided by 2 is 6. Okay, so continuing on to number 4. We have 2 more than, again, more than means plus, 4 times a number is negative 10. So 2 more than 4 times a number is negative 10. We go ahead and solve, so we subtract 2. That leaves us 4x equals negative 12. We divide each side by 4, and we get x equals negative 3. Okay? Number 5, 8 less than. Again, less than is that key thing we're thinking of where the order switches. Times a number, again, we're multiplying is, okay? So 8 less than 3 times a number. So instead of having the 8 first, because we see the word less than, we flip that around. So 3 times our number comes first, then we subtract the 8, is negative 14. All right, draw on our line. We have to subtract 8 that we want to get rid of first, so we add 8 on each side. That zeroes out on the left. 3x drops down. Negative 14 and 8 make negative 6. We want to get rid of the multiplication between the 3 and the x, so we divide each side by 3. 3 divided by 3 gives us the 1x, and negative 6 divided by 3 is negative 2. All right, number 6. We've got 3 more than the quotient of a number, and 2 is 7. So more than, okay, means addition, and quotient means division or a fraction of a number, and 2 is 7. So 3 plus quotient means we have division. I'm choosing to write the division with a fraction, okay? So our number goes on top, and then the 2 goes on the bottom, is 7. All right, we go ahead and start to solve, so we subtract the 3, and we now have n divided by 2 equals 4, all right? And we talked a lot about that hidden number next to the n, which gives us the fraction of a half. Anytime we see that fraction, we want to flip it over, and we want to multiply by the reciprocal on each side. So the reciprocal over here on the left side crosses or cancels each other out to give you 1n. And then over on the right side, 4 times 2 over 1 gives us the answer of 8. Okay, so 1 through 6 was more of those word problems or little sentences that translate into an equation. However, in number 7 and 8, this is more of a real-world type situation where defining a variable becomes more important because it actually stands for something, okay? So, number 7 says you buy 3 books that each cost, so we're buying 3 books, and each of them costs the same amount, and a magazine, all for a total of $55.99. You know that the magazine costs $1.99, so how much does each book cost? So, 3 books, okay? And the question is how many, or how much does each book cost? So I'm going to use the variable b, okay? So 3 times the amount for each book, plus our magazine, which is $1.99. And in total, we spent $55.99. Okay, we want to go ahead and draw on our line. We're going to get rid of the $1.99 by subtracting on the left side, which means we also subtract on the right side. It is worth noting here that when you're adding or subtracting decimals, that you're lining up your decimals over here on the right side. So $55.99 minus $1.99 would give you a total of 54. And then we want to go ahead and get rid of the multiplication by dividing each side by 3, which leaves us each book makes $18. Okay? And notice that I put the label down, $18. Okay? Notice a dollar sign goes in front of the numbers. Okay? A lot of times I have people put a dollar sign behind. That is not correct. Okay? It goes in front. The only time you put a symbol behind it is if you're talking about cents. Okay? Cents goes behind it. All right, number 8. A personal trainer buys a weight bench for $500, and W, they actually tell us what variable to use here because right behind it in parentheses, it says W is standing for the weights. For $24.99 each. Again, each means we're multiplying, okay? The total cost of the purchase was $849.86. How many weights, again, a key for why we're using the W for the variable, okay? So here we go, $500 plus $24.99 for each weight, and there was a total of $849.86 that was spent. We want to get rid of the $500 first. Okay, remember 500 really looks like that when you put decimals behind it. So that gives us $24.99 W equals $349.86. And then we're wanting to divide by $24.99 on each side. So that gives us W equals 14. And again, W stands for weights. So we are wanting to go ahead and do that and make sure that we are labeling our word problems. Okay? And that actually wraps up our notes for lesson 2.3.